One more numerical from chapter 1. At each of the four corners of a square of side A, a charge plus q is placed freely. What charge should be placed at the center of the square so that the system remains in equilibrium? So if we represent it in a diagram, this is how the diagram looks like. So four corners A, B, C, D. Charge of plus q placed at each corner. Unknown charge capital Q, which is to be placed at the center at the point O. What are the forces acting at the point A? There will be a force due to all the individual charges. So F1, F1, that is due to this charge, F1 repulsive, F2, F3 because of the charge at C, F4, this will be an attractive force due to this charge Q, because this charge has to be negative. All the four charges are positive, so this will be negative. Only then the system can be in equilibrium. And if the system is in equilibrium, then the resultant of all the forces acting at any point should be equal to 0. So let us see how we write. Since all the charges placed at the corners are positive, so to maintain an equilibrium, negative charge must be placed at the center. Since the system is in equilibrium, net force on any charged body in the system will be 0. So net force on a charge placed at A should be 0. The forces acting at the point A, F1. So F1, if we use Coulomb's law, 1 by 4 pi epsilon naught q square, because here the charge q and at the point A also q. So q square, if we take the side to be r, then q square by r square. Similarly, F2 also 1 by 4 pi epsilon naught q square by r square. F3 1 by 4 pi epsilon naught, again q square. But what is the distance? What is the length of AC? So it is a square. These sides are r square. So root over r square plus r square means root 2r, length of the diagonal. So root 2r whole square. So what we get is q square by twice r square. So F1, F2, F3. Now we should find F4. So F4, 1 by 4 pi epsilon naught, small q and capital Q. Small q and capital Q. What is the distance? Half of the diagonal. So diagonal was root 2r by 2 whole square. 1 by 4 pi epsilon naught, expand it, 2 small q capital Q by r square. Now simply we cannot add because F1 and F2 are at right angles. So resultant of F1 and F2, F12 has to be found out first. That has to be added with F3 and F4. So F1 and F2 are at right angles. So what is the resultant? F12 root over F1 square plus F2 square. If we calculate, this is what we get. Now we can find the net force. So net force F12 plus F3 plus F4 should be equal to 0. So we write all the values which we got. F12 which we got just now, resultant of F1 and F2, F3, F4. and V equal it to 0. When we solve this equation, this is the final term we get. So this charge Q should be placed at the center of the square, this.